Hello YouTube and welcome back to the Solar Shed, and this is a load of tungsten fairy lights all glowing away nicely, and they are consuming 18 watts, no 19 watts, so not a massive amount. And of course you can see the power factor there is 93%, which is what you expect. These are mainly a resistive load. Now these are quite old, and as you can see, some of them are different colours, but also some of them different brightnesses. So you've got some, say, really bright ones here and really dim ones here. So what we're going to do, we're going to convert these to LED, and you'll measure the power consumption and power factor again after they've been converted. So again, to convert them, I'm going to use the same capacitive dropper circuit that I've used in all my conversions. And this is a PCB I designed, and I've got about 50 of them. GLC PCB are the people I bought them from. Yeah, that's it, really. Just simple capacitive dropper, fuse, smoothing capacitor, and a bridge rectifier on the other side, and some bleed resistors. And that's pretty much all there is to it. So, plug has been removed, and new ultra-safe plug has been fitted. Now, this is just for testing. I will be getting a plug which is all encapsulated, enclosed, a bit like this one here. So that's got, this one here's got another circuit board like that in there, and I've got them coming. They're just not arrived yet. So this is just for testing, no finger pokey. So I've also wired it up so the most positive side goes to the first LED, and that's done so the highest voltage is over the shortest distance. It's kind of like a safety thing, but it's not really that safe. But yeah, that's the idea. So now I can plug this in, and then I can swap the bulbs for LEDs. I have shown this before, but to turn one of these to one of them, well, first we remove the bulb. Ugh. Bulb. One bulb. We then bend these little legs back here like that. Then the bulb can be removed from the holder. So we have a holder. We get our LED. We slide it in like so, and then we can just fold the legs back round like that, and then with a pair of cutters we can just cut the ends like that. And like that, and then we can fit that in the holder, and you have to make note which way around it goes. So the anvil, you see the anvil there? Come on, focus. The long bit goes then to the negative side. So to me, the short bit goes towards the plug. And that's it lit. You'll notice that with that power supply, the LED's lit, but the old filament bulbs do not lit. The only reason that this works is because the filament bulbs are intact. If you've got any blown bulbs, these won't light. But basically there's not enough current to make them filament bulbs light, but there's loads to power an LED. So yeah, it all works. So all I've got to do now is the same on all of them. That made no sense, but you know what I mean. Okay, so this is rather odd. I've changed all the bulbs to LEDs, and they were glowing nice and brightly, but now they've suddenly gone really dim. You can just about see there is a bit of a glow there. It's not much. Not much at all. So I don't know what's going on here. I don't know whether we've got one bad LED that's open circuit and all the rest aren't on, or if we've blown them all. Bugger. So with the lights off, these four here are not glowing at all. All the others have a faint glow. So either these four have higher turn-on voltages, or they're blown or open circuit. So I'm going to pop them out and see if they light up. And by using a coin cell and a bit of wire, I found this is the bad LED that doesn't light up. These three do. They'll go back in the circuit, and I'll change this bulb LED, same thing but different, much different. LED changed, and good news, it still doesn't work. Oh, it could be wrong. So annoying. Doing the same process, I've got another 4 in here that don't light up in the dark. Again, very dim glow. So again, I shall check these individually.
Right, these LEDs are all good. So they must just have a slightly lower turn on voltage, which doesn't actually matter in this string of LEDs.
So, is it my power supply? That'd be a bit odd if that's gone wrong, but it's not unheard of.
Again, taking safety to the uppermost limits, I've put the circuit board upside down on a power strip so I can probe the output. I've measured across an LED and I'm getting 0.2 volt. This is why they're not glowing. So this is a way I've devised to actually fault find the power supply so I can check the output, the input, and probe around some of the circuitry. So this supply seems to be working because at the output I'm getting 290 volts, which is effectively what would happen if this wasn't connected. So it would appear there's a break in the LED chain as suspected, although it's not the LEDs. So loose socket cable form, that's going to be fun to find. Well, that's annoying. I've gone through every single bulb and checked them all individually, and all the bulbs light individually, but when they're all connected into this string, they're just glowing dimly. So I think we have an open circuit somewhere, or high resistance, but I don't know where. This is why Christmas lights are rubbish and should be banned. Oh, I don't know. I might leave it for tonight and then I'll struggle on in the morning somehow. It's very annoying.